Hello and welcome to another one of D's ADD videos. Today we're going to be looking at E1 reactions. What are the steps and what are the conditions that make it ripe for an E1? So again, if we have a moderate to weak attacker like methanol, it's going to be a 1 reaction. Sometimes you can add heat in methanol and it will be an E1 reaction. It'll drive it more towards E1 as opposed to SN1. Usually when you have conditions ripe for a 1 reaction, you have a mixture of E1 and SN1. Alright, so what is going to happen? We're going to form a carbocation as always. We're going to have a rearrangement if possible, and then we're going to abstract an adjacent hydrogen in order to form a double bond. Leave the electrons behind and form a double bond. So the main rule that dictates the stability is called Zatsiev's rule. I hope I'm spelling that right. But it basically says the more substituted your double bond is, the more stable it is, and therefore the more major product. And we will go over that in its own video later on. This one will not, hopefully, requires Zatsiev if I made it up correctly. So here we have a wonderful compound that's going to be put in ethanol and heat. No, actually methanol and heat. And what's going to happen is you're going to end up with a carbocation right where the leaving group is. Alright, so then you ask yourself, are there any rearrangements possible? Well, moving one of these hydrogens here, the plus charge would go right here and it still would be secondary. Same thing on this side, and it was designed that way. So now what we got to do is we got to have the solvent do its thing. So what's going to happen is it's going to have a choice. It can either pull away. Okay, my tablet's frozen for some reason. Sorry about that. You can either abstract one of these hydrogens or one of these hydrogens, the adjacent hydrogens to your carbocation. So I will write my special hydrogens in orange, and then see those there. Now in this case, it does not matter if I pull the one on the left or the one on the right, because what will happen is the double bond will either form here or it will form here. And the way I've designed it is that it will be the same compound if you rotate it 180 degrees. So it doesn't matter which one you pull out in this case. So what happens is when I pull out, let's say this one here, and it goes and hangs out with your methanol, then you leave these electrons behind and they come over here and form a double bond. And in this case, your product will look something like, oops, didn't change the color, CH3CH, and then the double bond, and then the carbon, and the hydrogen, and the methyl. Okay, 1, 2, 3, 4, 3, 4. Oops, I forgot a carbon somewhere, didn't I? 1, 2, then the other double bond, and then there's a CH2, then a CH3. Sorry. No, sorry. Let's go. CH, then CH2, then CH3. Now, just to show you for completeness sake, I'm going to show you that you get the exact same thing. If I pull away this hydrogen, you would be left with a double bond there, and you would still have one carbon in front of the double bond, and then the 2 carbons of the double bond, and then 2 carbons trailing, just like I have right here. Okay, so in this case it was symmetric enough to where abstracting either adjacent hydrogen didn't cause you to get two different compounds, but a lot of times it will give you two different compounds, and that's when you use Zatsev's rule to determine which one's major product and which one's minor product. Okay, so I hope this has cleared up any confusion that you might have. Recapping, the main thing that let us know it was a one reaction was the ethanol presence. If we add heat, we can make it an E1 reaction. Check for rearrangements. Then once the leaving group leaves, abstract an adjacent hydrogen, leave the electrons to form a double bond. Okay? Hope that's cleared up any confusion that you might have. Practice, practice, practice. Thank you and have a nice day.